Lesson 3, Simplify Expressions. In this lesson, our I can statement says, I can use properties of operations to simplify expressions. Take a look first at the solve and discuss it question. How can the tiles be sorted? What I want you to try to do is see if you can figure out a way to sort these tiles into 3 groups. I'll give you a little bit of a hint. I'm going to place one tile in each group, and I want you to see if you can determine what other tiles would also go in those groups. So in group 1, the first tile that I'm going to place is the tile that says 3/8. In group 2, the first tile I'm going to place is the tile that says -5/10 x. And in group 3, the tile I'm going to place says 3/5 y. Now see if you can place the other tiles from the ones above, okay, in that picture. So we've used the 3/8, we've used the -5/10 x, and we used the 3/5 y. Can you place those other tiles in a group so that each group has something in common? Try that and then come back and check your answer. Take a look at each group. Can you determine what I used in terms of sorting? So what does each group have in common? Well, when you take a look at group 1, what you'll notice is that each of these is simply a single number. Sometimes you have a fraction, like 3/8 and 1/5, and other times you have decimals, like -5/10 or -4 and 25/100. And last but not least, the other number in this group is simply an integer, -2. But in all cases, these are just numbers, and we call these constants. In group 2, you'll notice that each of those terms has a variable, and that variable in those groups is x. So no matter what the number is in front of x, each of the tiles in group 2 is an x term. In other words, there's an x attached to that value. So that means in group 3, you'll notice that each of those are what we call y terms, because each of those tiles has a y value attached to the number. Now let's go on to example 1. The essential question in this lesson asks, how are properties of operations used to simplify expressions? Example 1 asks us to combine like terms with integer coefficients. So remember, integers are just positive or negative whole numbers. So take a look at the expression here and the algebra tiles used to model this. So let me get my pen. I'm going to switch some things out here. Okay, so in the very first part of the expression, you see 2 bars that each have a negative sign in front of the c. So right here we have -2c. Then you'll notice that we have 3 bars, and each of these bars just has the letter c on it. So we have 3 c's there. Then again, we have some tiles that have -1 on them. And those tiles, when you count them up, 1, 2, 3, 4, 5. So you have -5. Then you have some more tiles with C on them, and you'll notice that there are 4 of them. So that means -4C. And then last but not least, you'll notice that you have some tiles that have a +1 on them. And if you count those up, 1, 2, 3, 4, 5, 6, 7. That's a +7. So look here at each of these terms, and you'll notice that you see them here in this expression. So what we're trying to do is combine together the terms that are alike. So we group them together based on what letter is with them, or if they are just simply constant terms, which means only numbers. So you'll notice that the first thing that we do here in step 1 is we use what we call the commutative and associative properties to reorder and group like terms. So we're going to make a note over here about those properties. The commutative property allows us to switch the terms around. So two terms will trade places. The associative property allows us to regroup. And that regrouping typically means that we move parentheses around. So you'll notice here in the original expression that the terms are not next to each other when they can be combined. But you'll notice that you have all of these terms here with a negative sign in front of the C, and that altogether makes 6 of them. Okay, so you have negative 6C. And then you'll notice that you have some terms that have a positive C in front of them. And then you can put them together to get a total here. You'll see that right here, of negative 3C. Then look at the number parts. You have a negative 5, and then you have a positive 7. So when you put together negative 5 and positive 7, you end up with a positive 2. So we're grouping together the terms that are alike so that we can combine those terms together. In step 2, you'll notice that they have continued with the algebra tiles to show you how to put the terms together. So here are all of the C terms. Okay, so we have 2 of them, negative 2C, and then here we have negative 4C. Okay, that's this part right here. And then we have our positive 3C. And remember what happens when you put together a positive and a negative of the same value. So when I put a positive C and a negative C together, they actually make 0. And what's left are 3 of those negative C's. That's these 3 right here. Okay. Then we go on to the constant terms, or those tiles that have both positive ones on them or negative ones on them. So you can see here, this is your negative 5, and here is your positive 7. So again, we match up where we have a positive 1 and a negative 1 together because they make 0. And what's left are those 2 positives right here. So when we put these 2 pieces back together in the expression, we have a simplified expression of negative 3C plus 2. In the try it that goes with example 1, I'm going to show you how the book wants you to fill in the boxes that you see there, but I'm also going to show you another strategy. The strategy that I typically use when I'm simplifying an expression is to use different ways of circling or underlining or boxing out the terms that are similar and then put them together. So I'm going to illustrate that with your expression that says negative 6 minus 6f plus 7 minus 3f minus 9. So the first thing that I like to do is circle the terms that have the variable with them. In this case, the variable is f. So you'll notice that there is a subtraction sign in front of the 6f, which means it's going to be treated like a negative. You'll notice that there is a subtraction sign in front of the 3f, so it's going to be subtracted. And then I have a negative 6 term here. So that 6 is being subtracted. I have plus 7, so that's a positive 7 that you see here. And then I have subtracting 9 right here. So what we're going to do is we're going to put together the terms that have the f on them. And then we're going to put together all the terms that have just the numbers. So negative 6f minus 3f, do your keep, change. So keep the first number, change to addition, and change to a negative 3f. And what you get is a negative 9f, because negative 6 plus negative 3 makes negative 9. Then you need to worry about the numbers. Okay, the numbers only, you have a negative 6 plus 7 minus 9. So again, we're going to keep the first number. We have addition with the second number, so we're going to leave the addition. And then we're going to change the subtraction from minus 9 to plus a negative 9. Now we can enter those numbers into the calculator. Okay, if you don't know that answer, then go ahead and enter negative 6 plus 7 plus negative 9. And you should get a negative 8. So that means the 8 is being subtracted. So our two terms that are left are negative 9f and negative 8. And we put those together to make negative 9f minus 8. We could also write that as negative 9f plus negative 8, and that would also be a correct way of showing.